Now, when you're learning something, like you're learning how to use a tool, asking questions is the best thing you can do. So whatever happens in class, I want you to ask a lot of questions. So here's the name of this. What we're doing is called factor label conversions. Now, all right, so almost all of your chemistry teachers call it factor label method. Factor label method and is for converting. So the factor label method of converting is a very powerful thinking tool. If you were to go to college and go into physics class or engineering class, they probably don't like it calling factor label. So they want to make it sound very intelligent. So they will use their chapter, they would call it dimensional analysis. So if you want to go home today at dinner and say, what do you do in chemistry? Dimensional analysis. Whoa, that's why I'm paying all that money. No. Anyway, so if you want to make it sound like it's really, really fancy, you say dimensional analysis. But most people know it as factor label method. All right. So what we're going to do here is we're going to start out with a problem. And by the way, have we ever done any converting in here today, this year?
Yeah, temperature conversion.
We did temperature conversion, and we used an equation, didn't we? So that's kind of like a math equation thing. And we also did another kind of conversion. Metric to metric, that was a stair step, wasn't it? Well, this will do that. This will do stair step, but it also will do English to metric. I could change euros to dollar bills. Anything that can be converted, you can convert with this method. Okay? I want you to know how it works. If you know how it works, you'll understand, you'll always remember how to use it, okay? So here we go. I'm going to give you the first problem, and the first problem is 18, and I know there's two ways to spell donuts, but I like spelling it this way. 18 donuts equals how many dozen donuts? Okay, and you say, oh, wait, I thought you were going to teach me this powerful thinking tool, and what's the first problem I want you to work at? You say, wait, Mr. Fenia, why don't you just save a little time here? I already know the answer. Okay, now why did I pick a problem like this? Everybody knows the answer already, don't you?
1.5.
Right. So why did I pick that? Because
foundation.
I'm not teaching the answer. I want to teach you a new way of getting this answer so you can do some really hard problems later. But the way we do the donut problem, and I'm going to draw a line here, okay? Before the end of the period, you'll be doing this question right here. All right, can you do that one?
No.
You will. If you understand how the donut problem works, you will do this problem by the end of the day. Okay? All right, so you have to trust me a little bit here. All right. Well, number one, first of all, I'm not sure I have to make sure that you are worthy of me teaching this to you. And so in order to do that, I'm going to give you a little pre-quiz. Okay, now, you have to answer my questions before I think you are worthy of me to teach this to you. So here's my first question, and here we go. Do you believe that any number times 1 equals the original number?
Yes.
Now, wait. I want you to think about this. I want you to think about this because you were so fast. If you're so fast and you said yes, and there's one example where it doesn't work, then the answer is no. Did you try 0? Is 0 times 1 equal to the original 0?
Yes.
All right, so the question is, do you believe, quiz question number 1, do you believe that any number times 1 equals the original number?
Yes.
Wait, you tried 0, but you did not try a negative number.
Oh, good point.
Negative. Okay, now, oh, wait. The thing is, you're not showing me you're worthy if you answer without testing. Okay? Now do you believe that any number times 1 equals that original number?
Yes.
Okay, all right. You are worthy to proceed to the next step. Next one. Are you ready? Are you ready? Okay. Do you believe that 12 donuts equals 1 dozen donuts? Now, wait a minute. Think about it.
Yes.
Did you test it?
Yes.
Okay, what about a baker's dozen?
No.
What is a baker's dozen?
13.
13. But you know what? I didn't say a baker's dozen, so it didn't say baker's dozen, so it is still true. Do you think this is true?
Yes.
Okay. All right, you are worthy to proceed to the next level. Next, do you believe that any number except for 0 divided by itself equals 1? Be careful.
Yes.
Except for 0, is any number divided by itself equal 1?
Yes.
Negative number.
What? No.
All right, except for 0, do you believe that any number divided by itself equals 1?
Yes.
Give me one. If you give me one example where it's not true, then I'll say it's not true.
0.
All right, are you ready? Now, you are now ready to proceed to your final exam.
Is this like a certification?
This is your final exam, and this is important. You may not shout out the answer. You may not talk to anybody. You may not ask me a question. I'm going to put a final exam. I'm going to put a final exam question on there, and I want you to write down your answer. Now, if your answer has a number, make sure you put a number. If your answer has a label to it, then make sure you have a label. Okay, you may not, after I write this down, you may not ask me a question, you may not talk to anybody, and I want you to cover it up when you get done. Okay? Are you willing to do the final exam? Here we go. All right, everybody quiet, and after you put your answer down, cover it up, don't let anybody see it. This is your final exam, and if you pass this, you will be worthy of me teaching this to you.
Use my calculator.
Okay, wait a minute, don't talk. Cover up your answer.
We're screaming out.
Okay, anybody need more time? Okay, now, please, this is important to me. I've done this 30 years. I know what kind of answers are going to come out. I know that everybody in this room is not going to have the same answer. You got that? All I ask is that you tell me what you actually wrote down. Don't have this peer pressure thing where you might be the only person that wrote it down and you might be correct. You got to understand that, all right? So we'll start over here and just tell me one possible answer. What do you think the answer is? One what? Just one? Just one? Is that what you wrote down? Just one? Yeah. You didn't put anything after it? No. Okay, that's a possible answer. What do you have? Okay, and what do you have?
I said 1 dozen.
Okay, and if you have something different, let me know. What do you have?
I said 1 donut.
1 dozen?
1 donut.
1 donut, yep. Next,
I put one donut.
just 1 or 1 donut?
One donut.
Okay, so you already had it, right? So if I go around the room, say it's already up there, or give me some, if it's not up there, tell me what you have. All right, go.
One.
Okay,
Well, I said 1 dozen donuts.
okay. What, 1? Already up there?
Maybe it is 1.
Already up there? 1 donut? Okay,
Or now you feel stupid.
One.
just 1? Just 1.
If you
Okay,
want any-
now, before I proceed, is there anybody else? I can't believe there's an answer that almost always shows up, and I can't believe if somebody didn't give it to me yet.
Is it normally
0, okay, that didn't show up, and I am very surprised that 12 or 12 donuts didn't come up. Does anybody actually had that and they didn't want to raise their hand? Okay, well, I want to tell you that I usually get 4 answers. I only got 3 here. That's interesting to me. I thought for sure somebody would, get, but we only have 3 answers, okay? I've had it many years where the actual answer was not up here. In this case, it is. The actual answer is one of these 3. Now, I want to tell you something, that if you didn't write the correct answer here, then you are lying to me. Okay, here is the correct answer. Now, if, oh, wait now. Wait a minute.
Well, you said that.
Wait.
We lost those.
Okay, wait, stop. Listen. Let me tell you why you have been lying to me if you didn't put this. All right, watch now. You told me that you believe that 12 donuts was the same as 1 dozen. It is the same. That's what you said. They were equal, right?
Yeah.
You told me that except for 0, anything divided by itself has to equal what? Not 1 donut, not 1 dozen. It equals 1. Now, I'll come back to this in a minute. Why'd I have this as one of your test questions? And by the way, what is 1 dozen donuts divided by 12 donuts? What does that equal? 1. Now I will teach you factor label, okay? And I will teach you how to do this problem, which will tell you how to do this problem. Okay, ready? Step 1. Step 1 is always write down the given. Now, when we start, I'm going to make you do something that later I won't make you do it. But when you start, I'm going to actually write 18 donuts. And I want you to put a big G up here to remind you that that's the given. Now, I'm going to put this over 1. Now, the reason I'm doing that is even in elementary or middle school, you were taught that 3 was the same as 3 over 1. So guess what 18 is? It's the same as 18 over 1, isn't it? But they didn't teach you what a donut was, and a donut is the same as a donut over 1. So 18 donuts is the same as 18 donuts over 1. Everybody got that? No big mystery there. Now, the reason I had to do that is you need to know who's in the numerator and who's in the denominator. Everybody get that? Now, that's step 1. Step 2. Multiply the given by a conversion factor. Now, this is where you have to pay attention, okay? This is where you have to pay attention. We have a fancy word for things that are equal to each other. They are called equivalents. All right, what are equivalents? What are equivalents? Things that equal each other. 3 feet equals 1 yard. They're equivalents, aren't they? You okay? Now, what you're going to do is take equivalents and make a ratio out of them. And out of this equivalent statement, I could make this one and I could make this one. Okay, now, conversion factors are made from equivalence. All right, so let's try it. Here is 12 donuts equals 1 dozen. They're equivalent, aren't they? There are two conversion factors you can make. One with donuts on the top and one with donuts on the bottom. You get that? Where do you get equivalence? I'm sorry, where do you get conversion factors? You make them from what? Equivalence. That's important. Now, here we go. Step 2. Multiply the given by a conversion factor. Where do I get my conversion factor? I make them from equivalence. All right. Now, which one of these do I need to use? Now, I don't want it to be a guessing game, so here's where it's simple. This is the key to factor label right here. Do you want to convert donuts into something that's not donuts? Then how do you get rid of the label called donuts that's in a numerator?
Multiply by the denominator.
That's right. And what would you like your final label to be? Dozen?
Does.
Okay. Now, tell me what's equivalent here. What's equivalent here? Don't look at the problem. Tell me what's always true about donuts and dozens. 1 dozen is what? That's always true, isn't it? These are always equivalent to each other. Now, again, how do I know to put this one? Because I want to do this, and I know, please allow me to be picky here. When I give a quiz on this, you guys have to be certified also. I'll give a certification thing. You will get, if it's a 10-point problem, you will get 2, only 2 for the correct answer. You'll get 8 for showing me the factor label work. You get that? That means you can show me the factor label work and miss the problem, and I'll give you 8 out of 10. That's how serious I am on the method. I'm not that interested in the answer. You are going to get the right answer, but it's the method that's going to help you. And trust me, the problems get way more complicated than these. You get it? So let's try it. Now, what's happens here, you will get points for taking a single line and crossing out the label that gets crossed out. Not the number. You're not crossing out numbers. You're crossing out the label. Now, next thing is, when the only label that's not canceled is the one you want, only then do you put equals, and only then do you pick up your calculator. Don't pick up your calculator until the label that's left is the one you want. Okay, now, real quickly, any number that's in the numerator, this kind of a problem, you multiply by it. Any number that's in the denominator, you divide by it. But multiplying by 1 and dividing by 1 will not make a difference, so you simply put in your calculator 18 divided by 12, and what are we going to get here? Now, I'm going to show you how nice I am. If you ever leave your label off the answer, I will take off a point. That's how nice I am, because if you don't put the right label, there's some reason why. So what are you going to do here? Okay, now, are you ready? That is how you do factor label. That's the simplest kind of factor label you can do. Now, I'm going to give you a minute, maybe 2. Do what you're supposed to do down here. Ready? And go. All right? Do what you're supposed to do for this problem.
What are those words over to the right?
Moles of sulfur. 100 grams of sulfur equals how many moles of sulfur? Ready? Do what you're supposed to do and go. You said you were worthy of me teaching this to you. If you're worthy, you'll know exactly what to do. if you're worthy, you know what to do. I really don't want to sit here all period. So I'm really waiting for something. I'm waiting for something that should have happened.
Oh, we
Before.
have to know what a treatment thing is.
What now?
We have to know what the thing is so we can convert
Thing.
the other,
Unit.
what moles means.
What are they called? What do you call them?
Will, you're more.
Are moles an animal in this case, or?
No. It's actually a very, very important chemistry term.
Hold on, Will.
All right, here we go. Okay, here. Everybody in the room should have done step 1.
Yeah.
Yes.
All right, and then if you were worthy, you should have raised your hand and says, I can't do any more because I don't have the, no? Equivalent. Who said that?
I said that.
Yes, all right, listen, I don't have the equivalents. Now, what I'm going to show you is, we have an entire chapter on this, but I don't need to teach the whole chapter, chapter 7. I want to teach you a little bit about equivalents and moles. This is true. This is always true. 1 mole of sulfur is equal to this many pieces. And they're called atoms of sulfur. And that's always true. Like if I said 1 dozen eggs, you wouldn't ask me how many, would you? You know it's 12. 1 dozen baseballs, you know it's 12. 1 dozen sand grains, you know it's 12. In the chemistry world, a mole of anything is this many. That's a huge, huge number. Now, you don't question why. Why is a mole? It is a mole. You don't question why is a dozen 12, do you? It is that many. Now, one more thing. I want you to look on the periodic table. And I want you to look at the decimal number associated with sulfur. Look at the decimal number associated with sulfur. Can you see it? 32.06, right? 32.06 grams. If you put grams after that, you now know how to do the 3 equivalents. You know how to do the 3 equivalents for sulfur. All right, now go ahead and do the problem. I know we just learned it, okay? I know we just learned it. Does everybody have step 1 down?
Yeah.
You write a little G here for given. Okay, and then I had to multiply by a what? What's a CF? What's a CF? Conversion factor. Okay? Where do you get conversion factors? You make them from equivalents. How do you know who goes down here? This is important. What label, forget the numbers, we'll get the numbers in a minute. What label has to go down here? Not just grams. Grams of what? Grams of sulfur. And what would you like to replace it with? What would you like the answer to be in?
32.
Don't tell me about a number yet. Moles of sulfur, okay? You all right? What label had to go away? And how do you get rid of grams of sulfur in the numerator? You multiply by something that has grams of sulfur in the denominator. And then these have to be equivalent. Most important thing I'm going to say today is don't ever get these numbers from the problem. Do not ever get these numbers from the problem, okay? I already wrote the number for the problem. Where do I get these? From equivalents, aren't they? Tell me about what's equivalent with moles of sulfur in grams every day. Every day. What's equivalent?
33.
Let's take a look. Watch. I do this weird thing that I don't mind being weird if you'll remember it. Watch. What number goes here? I'm looking for grams. Ready? No. No. Yes. Okay, so then I know that that number there goes with grams, and now I'm looking for moles. No. No.
No.
Yes.
Yes!
And now, you know, I don't mind being foolish, but on the quiz or the test, if you put the 32 up here and the 1 down here, I got to ask you, why in the world would you put it that way? Why would you put the 32 up here with moles? Why? All right, ready? You get points. You get points for taking a single line and crossing this out. Everybody get that? You get points for taking a single line and crossing those out. Now, what's the only label yet left?
Mole.
Is that what you wanted?
Yeah.
That's the only time you put equals, and now you pick up your calculator. Let's do the problem. You don't even know what a mole is in chemistry, but you're going to be able to do the problem. Have you done the problem? You got it? You got it? Okay. Now I just made this problem up, so I don't know what the answer is, but it's going to be something about 3 point something, isn't it? What is it? 3 point what?
119.
119? Okay. I like to round to 3 sig fig, so 3.19, wait, 3.119?
3.12.
3.12?
That would be if we round.
Okay. And that's not correct yet because we don't have a label.
Mole.
Moles of what?
Sulfur.
Okay. All right. What do you think?
That's hard.
Now, let's do another one by yourself. No help. No help. Ready? Okay.
I'm scared. This one's gonna be hard to do, especially.
All right. Ready? 1 billion atoms of carbon equals how many grams? Now, I'm going to give you a hint, and I'll be quiet. Since you're just starting out, I would go up here and write the 3 equivalents that are about carbon. 1 mole of carbon equals what? 1 mole of carbon equals what? 6.02 times 10 to the what?
Where do you get 6?
What, a dozen is always 12, right? What's a mole always?
6.02 times.
Today is the 19th. Guess what October the 23rd is?
The first day of the
At 6:02 a.m. and 6:02 p.m. That's Mole Day.
Mole day.
Mole Day is 6:02, 10:23. Okay? Uh-oh, now, where did I get that third number? Where did I get that third number? Where is it? Where is it? Okay, now go ahead and do this problem. Sit with somebody. We only have about 3 minutes, and I would like you to see if you can get this right. We're just starting out. So sit with somebody, and imagine you get 8 points for the factor label, you get 2 points for the right answer. All right, go sit with somebody, and we have 3 minutes.
Okay. So you can join us for that, but I don't know if they're smart enough to cheat me. That's a joke. I'm just. So then you have this.
I'm going to mute the screen and put the answers down.
Given number. What's the given number? Oh, because it's perfect.
reason you need to talk this out, it's the first day you've learned this, you have to talk it out and it'll stay with you longer. Then I want you to, when you get an answer, I want you to turn around to somebody else's group and see if your answers match. We have 2 more minutes. We have 2 more minutes.
Just break it up. Just add one.
What time's class?
1 more minute. All right, listen up. Since I only have 1 more minute, if you look up here, everybody look up here for a minute. Everybody look up here. Now, if you set it up this way, you understand. I needed to get rid of what label? And I changed the billing into 1 times 10 to the 9th. And I needed to get rid of atoms of carbon, so I put atoms of carbon down here. Did everybody do that? What did you want to convert it into? Grams. Well, I had that. And you said, but you didn't use mole. I didn't use it for this one. I don't need it for this problem. So, now, some of you have set it up correctly. You're still going to get the wrong answer, some of you, because of PEMDAS. Now, watch again. You would say 1 times 10 to the 9th times 12 divided by, you better put parentheses around a scientific number in the denominator. If you don't put parentheses and say divided by this, it'll divide by that, and when you say times 10 to the 23rd, whoop, it'll shoot it up to the numerator. So ready? 1 times 10 to the 9th times 12 divided by, parentheses, 6.02 times 10 to the 23rd, close parentheses, enter. All right, you got about 10 seconds. Everybody get that and look at your neighbor. And I have no idea what the answer is because I made this problem up. But does anybody have the answer? And we're going to round to 3 sig fig scientific notation. Does anybody have the answer? Billy, you have it?
No.
Anybody? Reese, you have the answer? Almost?
1.6.
1 point what?
66.
Say it again.
1.661
Times 10 to the what?
times 10 to the negative 15.
Negative what?
15.
Does everybody know the E on a calculator means times 10 to the? Is everybody getting this answer?
I don't, where do you get the 12 and then?
Where do you get the 6.2?
Okay, where do I get, how do I build a conversion factor from what? From what? From equivalence. So 12 grams of carbon is the same as what? As that many atoms. We're going to do this all again tomorrow. We're going to do it all again tomorrow, okay? All right, thank you very much.